In this video, we introduce Origraph, a data wrangling tool for network data. In the companion paper, we describe 12 network reshaping operations that can be used to transform networks in many different ways to answer specific analysis questions. Origraph implements all of these operations in a web-based system that analysts can use without having to write code. Origraph has three main views. The network model view shows the relationships between node and edge classes. The attribute view shows the items of node and edge classes and their attributes. The network sample view visualizes a sample of the network with instances from each class in the network model. We demonstrate Origraph using a dataset of movies and actors, which we retrieved from the movie database. We retrieved the 50 most popular recent movies and details about the cast and crew in each of these movies. The resulting network has 9,000 nodes, 10,000 edges, and 8 different classes. We are interested in investigating issues related to gender bias in the movie industry. We retrieved 3 raw tables from the TMDB API: movies, credits, and people. After importing these files, each one is represented as a generic class and visualized as a diamond shape in the network model view. We start by defining the movies as nodes. We then shift our focus to the credit class. The credit items contain complex nested objects. For example, the attributes cast and crew contain objects listing the whole cast and crew for each movie. We can unroll these nested objects to create separate node classes for cast and crew, respectively. The cast class contains a list of roles and the name and ID of the person that played that role. Similarly, the crew class contains roles, names, and IDs of the crew members. Since we no longer have a need for the credits, we delete it from our model. We want to connect people to movies using cast or crew as the edges between them. To do this, we define people as nodes and cast and crew as edges. We then connect both cast and crew to people and movies. We use the connection interface to connect the cast edges to the movie nodes based on a shared ID. The connection interface is used to connect 2 classes based on shared attributes. Origraph computes a score to guide the user in choosing attributes that match. These scores are shown in a ranked bar chart. Attribute combinations with high scores are likely good matches for connections. For a selected pair of attributes, histograms display the degree distribution for both source and target classes. Together with the table view, these views ensure that a connection is meaningful. We do the same for connections between cast and people, movies and crew, and finally, crew and people. We now have the basic network model built and can explore specific nodes and their connections in the network sample view. To explore the movies of a specific person, we add that person to the network sample view and reveal all of their neighbors. Here, we can see all of the movies that Stan Lee has been involved with. We are ready to calculate the gender bias for each movie in terms of its cast. To do this, we have to access the gender of all the people who are connected to a movie via a cast edge. We can achieve this by deriving new attributes across connected classes. In this example, movies are connected to actors. To get to the number of men and women in each movie, we access all actors connected to the movies. We introduce a dedicated interface that lets analysts specify a path along which to follow the network and to select target attributes. Here we select the path movies, cast, people. Since we are interested in the gender of all cast members of each movie, we select gender from the list of cast attributes. Origraph provides a series of default aggregation functions, of which we select mode to see what is the most common gender in each movie. The preview window shows the computed attribute for all the movies in our movie class. To calculate the gender ratio, however, we have to write a custom function. The code window is pre-populated with the mode function, and we only have to slightly modify it. We divide the number of men by the total number of cast members. The result is that a movie with only men has a value of 1, a balanced cast has a value of 0.5, and a female-only cast has a value of 0. If we sort on this attribute in the table, we can see that Ocean's 8 has the lowest gender bias, and Black K Klansman has a predominantly male cast. At this point, we might be interested in the gender bias of specific production companies. For this, we must reshape the network to represent production companies as their own class. Production companies are an attribute of the movies table, so we unroll the production companies into their own class and rename it to produced by. This, however, results in duplicate production companies. We can resolve these duplicates while preserving all connections with the promote attributes operation. Promoting an attribute creates a new class containing items for every unique value of the promoted attribute. In order to connect movies directly to their production companies, we convert the produced by table to an edge. Since Origraph supports complex edge attributes, these edges preserve all the attributes of the original data. We can explore the network in the network sample view, but Origraph also supports exporting the final modeled network to other tools, such as Gephi, which we do here. We then load the movie network into Gephi, where we can perform more exploratory data analysis. Thank you for watching our video.